So in this video we'll be learning how to find the center of mass of a ring, of a half ring, semicircular ring. So in the diagram we have a semicircular ring, and since we have to set up integration in the future, what we do is we consider a thin segment of the ring with such that the arc subtends an angle d theta. So the length of this tiny arc is going to be r d theta. Since d theta is basically length of arc divided by radius, by rearranging it, we get length of arc as r d theta. And let us say that the y coordinate of the ring of this arc, since this angle becomes some theta, we can say that the y component is going to be r sine theta. So now, with this much information, we can get to the integration. We know that a semicircular ring has one axis of symmetry, which is this. So we know that the center of mass must lie somewhere on this line. It could be here or over here. So all we have to do is find the y coordinate. The x coordinate is already known to us by symmetry. So we can say that the x center of mass is 0 and the y center of mass is what is unknown and needs to be found. The y center of mass can be given as integration y into dm divided by integration dm. Since integration dm just becomes m, and we are assuming this to be of linear mass density, so there is no variation of the mass distribution, so we can just call this m. So let's say that this has a capital mass m and radius r. So dm is basically the small mass that the tiny arc has, and we can write this dm as a ratio of r d theta and the entire ring. So how we would do that is first get the ratio of the length of the tiny arc to the length of the semicircular ring. So we have r d theta divided by the length of the ring is obviously going to be 2 pi r by 2, and the 2 just gets cancelled and we're left with r d theta by pi r. And this small ratio that we have, when you multiply this with the entire mass, you get the tiny mass of the arc. So we'll be substituting this into that equation. So we have integration. As I said earlier, the y coordinate of the arc is basically r sine theta. So we have r sine theta into r d theta divided by pi r into m divided by m. So what we essentially did was we converted an integration over dm into an integration over d theta. So we can simplify this, the m and m, since m is a constant, it can just get cancelled. So what we have, and again this r and this r gets cancelled. So what we get is r over pi. Since r and pi are constants, you can take it out of the integration sign. Integration of sine theta d theta. We can see that the theta, since we have to cover the entire length of the semicircular ring, the theta ranges from what was essentially 0 degrees over here, and it goes all the way till here where it becomes 180 degrees, which is pi radians. So we have from 0 to pi. And an easy way to remember the integration and differentiation is by drawing this thing. Sine theta minus sine theta cos theta minus cos theta. If you go in the clockwise direction, you're basically taking the differentiation of it, and if you go in the anti-clockwise, you're taking the integration of it. So we can see the integration of sine theta is minus cos theta. So this is r over pi into minus cos theta from 0 to pi. By substituting the limits, you get r over pi. So cos of pi is basically minus 1 times minus 1 is 1, and you subtract this with cos 0. Cos 0 is 1, and this becomes negative here, so you get negative 1. So you get 1 plus 1 minus minus 1 is 2, so 2r over pi. And this is the center of mass, the y center of mass. So it's going to be somewhere around here. Thank you.